It's time for video 1A. This is Mr. Miller. I hope you're doing well. In this video, we're going to talk about evaluating functions from the rules and from graphs, and also about interpreting function notation. It's going to be good. So let's start with our first examples here. So a function is any rule that takes an input and generates an output. You take the input, you do something to it, you get an output. All right, so this function is called feed me. We put in an input, and the box here describes what happens. We take the input, we square it, which means multiply it by itself, and then we're going to subtract 2, and that's how we get the output. So what this arrow notation means is we're going to put the number 8 as an input into the function feed me. We're going to see what the output is. So when we put 8 in and we square it, 8 times 8 is 64, and then subtract 2, we get 62. So I like this arrow notation. 8 goes into the function feed me, out comes 62. Negative 13, when we put that in and square it, well, we have to use parentheses around negative 13 when we square it. You should get a positive 169, because a negative 13 times a negative 13 is positive 169. If you don't use parentheses when you square a negative number, you're going to get the wrong answer on your calculator. So negative 13 squared is 169, and when we subtract 2, we get 167. This is the more common notation here. It has the name of the functions, then parentheses, and what the input is. This means we're going to put 5 into the function feed me and see what we get. So 5 squared is 25 minus 2 is 23. So 5 is the input, feed me is the function. When we put 5 into it, we get 23. On this one, we're going to put 12 into the function feed me and find the output. 12 squared is 144, and if you subtract 2, you get 142. That's how that works. All right, here we have a rule specified using arrow notation. Whatever the input is, we're going to put it in the function freshie, and we do 2 times the input plus 7. So when we put 4 into the function, we're going to do 2 times 4 plus 7. 8 plus 7, that's 15. That's the output. When you put negative 2 in, 2 times negative 2 is negative 4, plus 7 is 3. And when we put 0 in for x, 2 times 0 is 0, plus 7 is 7. So that's how we evaluate a function. We substitute the input into the rule for the function. So freshie of 10, this means we're going to put 10 into the function freshie. So 2 times 10 is 20, plus 7 is 27. If we put 42 into the function, 2 times 42 is 84, plus 7 is 91. And when our input's negative 3, substitute that for x in the rule. 2 times negative 3 is negative 6, plus 7 is 1. Okay, this example has something very important in it. There's something we have to be aware of when the rule involves squaring a number. So here, x is the symbol for the input, and this f of x is what we get as the output. Okay, and this is the rule for it. So this means put 6 into the function f. So we're going to put 6 in, so we get f of 6 equals, well, 6 squared minus 4. 6 squared is 36 minus 4 is 32. That's the output when x is 6. If we put negative 2 in, we have to be careful. When we put negative 2 in for x, we need parentheses around it. So negative 2 squared minus 4. Negative 2 squared is positive 4, minus another 4 is 0. All right, when we put 5 in, 5 squared is 25, minus 4 is 21. And if we put 1 in, well, that'd be 1 squared minus 4. 1 minus 4 is negative 3. So sometimes you'll be asked to evaluate the same function for several different values, and we can organize it into a table. So our function name is h, and this is how we compute the output. You do 20 minus 3 times the input. So it wants us to put 6 in for x and compute the output. So the output would be 20 minus 3 times 6, 20 minus 18, which is 2. If the input were 9, we're just going to change that to a 9. If you're using a calculator, you can cursor up, find the expression, and just change that 6 to a 9. But that would be 20 minus 3 times 9, which is 20 minus 27, which is a negative 7. All right, we're going to put in negative 2. H of negative 2 would be 20 minus 3 times negative 2. Well, that ends up being 20 plus 6, because that's 20 minus the negative 6. It's the same as 20 plus 6, which is 26. So if you have a table, it's no problem to complete it. You're evaluating the same expression, just different inputs. All right, a couple of things to go over here. It's not too much problem when we put in 6. If we want to find h of 6, we're going to substitute 6 into every place we see an x in the rule. So that would give us 6 squared plus 2 times 6 plus 3. All right, so that's 36 plus 12 plus 3. I think that's 15 and 36. You get 51. No problem. Just grab a calculator, plug it in. You do have to be careful with this, though. We're putting a negative 2 in for x, and we're squaring it. We need parentheses. Negative 2 squared plus 2 times negative 2 plus 3. Okay. It's okay to use parentheses around negatives whenever you substitute them, but especially when you square them. So this would be 4, and that would be minus 4 plus 3. We end up getting 3. Another important thing about evaluation is when there's division, you have to simplify the numerator first, and then simplify the denominator if it's not simplified already, and then you divide. So when we do f of 6, first step, I'm just going to put 6 in for x. All divided by 4. You got to be careful with your calculator. If you want to do it all in one step, you got to put parentheses around the numerator. It's all of that divided by 4. So we got to simplify the numerator first. 36 minus 12 is 24, plus 8 is 32, divided by 4. Now we can divide. 32 divided by 4 is 8. All right, that was the hard part. Now comes the quick part. Evaluating a function using a graph. So when the input is 2, you find the input on the x-axis, you go up to the graph where it crosses, go up until you cross the graph or down, and then you read off the y-coordinate of the point where it meets the graph. The y-coordinate is 6. When the input is 8, go over to 8 on the axis, go up to the graph, read off the y-coordinate is 3. At 4, looks like the output is 5. At 0, that's the y-axis. If you go up to the graph, it crosses the y-axis at 7. All right, so once you get this hang of it, find the input on the x-axis, go up or down to the graph, and read off the y value. Those are no problem. So this is a graph of function p, and we want to know p of 2. So when we put in 2 as the input, we're going to go down to the graph and read off the y-coordinate. That's negative 3. At 5, it's right where it's already at where the graph crosses. It's already where it crosses the graph. So if we read off the y-coordinate, that's 0. If we put in 3, it goes all the way down here, and the output is negative 4. If we put in 1, that's another place where we're already at, where it crosses the graph. So at 1, the y-coordinate is 0. Okay. Now, we're almost done with this. This is from IXL, and this is one of the skills we need. It's interpreting the function. So it says the speed of a baseball, x seconds after the pitcher releases it, is given by the function f of x. The speed is measured in meters per second. So the input is how long the ball has been in the air since it was released. That's the input, the seconds. The speed is given by the function. That's the output. So it says, what does f of 0.3 equal 39.8 tell you? Well, the input is the seconds, and the output is the speed. So after 0.3 seconds, the speed is 39.8. So I think that's this one. The ball has a speed of 39.8 meters per second, 0.3 seconds after it's been released. It's kind of tricky and confusing, but you got to sort out what's the input and the output. The input is the seconds, the output is the speed. So 0.3 is the seconds, 39.8 is the speed. Let's try one more, and we're done. So Mr. Blackburn is smoking a turkey for Thanksgiving. The instructions for the smokers say that approximately f of x hours of smoking time, that's the output, smoking time, is required for a turkey weighing x pounds. That's the input. So the input is the weight. So f of 20 equals 10. Well, 20 is the weight, and 10 is the smoking time. So let's see this. It will take 20 hours to smoke a 10-pound. No, the weight is 20. It will take 10 hours to smoke a 20-pound turkey. This is the correct one. That practice is available on IXL. They have a video also if you need a little bit more explanation. But it's just a matter of identifying what the input is and what the output is and looking for the right explanation. Okay, there was a lot of information here, so I hope you made it through it all, and see you in class.